Let's talk about gameplay-based post-processing. Here we can look at the example of the player's health affecting post-processing effects. To do this, I'll pre-create a tower that can spawn projectiles that apply damage to the player character. You can use any sort of damage system that you have in your game, but what you really need is the player character to have a health variable that changes somehow. Now we want this health variable to affect post-processing effects to help further feedback for our game. In order to do this, we can have a post-processing controller that listens to broadcasts when the player is damaged. Now these broadcasts in Unreal Engine are called the event dispatch system. So we'll have the player character notify anybody who will listen about damaged events. Then this post-process controller can go ahead and modify the post-processing material based on the current health of the player. Let's begin. I've opened up the third-person template, gone ahead and made some towers that shoot out projectiles at the player. When these projectiles hit the player, they'll do some damage. And we'll use this health system to modify post-processing effects to change the scene however we want. You could go ahead in your game, use any sort of health system that you already have, and tie it into this sort of post-processing effect. In here, we'll create a new material, call it M post-process. Open that up. Well, for this post-process, we'll have to go to our material domain, switch it to post-process. In the post-process material, what we'll try to do is tint the world a certain color as the player gets more injured. So let's tint it red as the player gets hurt. And we'll also look at making things farther away darker. So as the player gets hurt and damaged, things that are farther away turn blacker and blacker. First, let's look at how we can change the tint using this post-process effect. What we could do is use a scene texture. Now, the scene texture, we can grab different types of data from the scene itself for post-processing. The default that you get when you first search scene texture is scene color. We'll open up this dropdown on the side and look for post-process input 0. So this will be our basic post-process input. If we connect our color to the emissive color, then we just get the scene back. So here we haven't really changed anything. We can go ahead and test that by going to our map, going to our post-process volume. Under post-process materials, we can add a new one. We can add in our post-process material, but first let's create a material instance for it called MI post-process. That way we can change the parameters within our post-processing. Go ahead, click on this MI post-process, close our menu, choose, and we'll use the selected post-process material instance. Now here we can see we've applied this material instance and the scene looks the same. If we disconnect this line, this connection, and save it, our scene will go black. So this color from the post-process input 0 is just our base information in the scene. Now to modify this post-process input, we could go ahead, we want to add a new vector 3, and we'll convert it to a parameter and call it tint. This will be whatever color we choose to tint the world. Here, let's do the default as pure white, 1111. And we could take our input base color and multiply it by our tint color and drag that into our emissive color. We'll see here we get an error. In some cases, the Unreal materials will treat colors as a vector 3 instead of a float 3 instead of a float 4. So what we could do here to remedy this is add an append vector, drag in our first pin, our second pin. So this will be our alpha. It treats our color as a RGB with no alpha, so we'll add just an alpha of 1 at the end and use that as our multiply node. Then that should work. So test that this tint works. Let's tint it blue, save and apply. We've tinted our world blue, perfect. Return this 1, 1, 1. So later we can modify this tint color to tint the world as the player is damaged. Now to make things darker that are or farther away darker, let's open this up a bit more, zoom in. We can add a scene texture. This is our same node here. For this one, we'll go over to our drop down on the side and we'll look for scene depth. So the scene depth contains depth information in the scene. This allows us to see what's closer and farther away. Let's test and see what that looks like when we connect it into our emissive color. We'll see everything is white since the scene depth has values greater than 1. So everything greater than a value of 1 is going to be blown out for a color. And this is because everything in the scene has a value equal to the distance it is from the camera. So in order to deal with this, let's first think about the scene depth as the greater the value, the farther something is away. So if this is a value of 0, it's right next to the camera. Now we can flip that around. If we drag out from our color and do a 1 minus, this will invert our values. We'll take 1 minus our color and invert it. This means everything very far away will have a value of 0, and close by will have a value of 1. So this way, if we want to multiply later our color in, things farther away will be black and dark, since we're multiplying it by a value of 1 far away and a value of 1 close up. Let's drag out from our 1 minus. Here we can add in some amount of offset. Well, first let's test our 1 minus and see what that looks like for our emissive color. Yeah, so we've made everything black. So that inverted our value. Now everything's too small and shows up as black for its color. So let's add in an offset value. Here we'll drag off of this, or we'll add a new float value, drag that to our add. Promote this to a variable, and we'll call it offset. This offset value, this will be some distance amount. Let's call it 5,000. Now our values will definitely be outside of our range from 0 to 1, but we've created some amount of offset. Let's see what this looks like. There's a harsh line at that 5,000 units away from the camera. So if I change this to 50,000, now we'll see the line is even farther away. Now we can normalize this. We'll divide by our 5,000 again, our offset value again, to bring it back into a range of 0 to 1 to get that nice gradient. Here you can see things farther away are turned black. And if I zoom out real far, as we get farther away, everything fades to black. All right, now let's combine these two. Combine the scene depth and our color information that we can tint. We'll multiply them together, add that to our emissive color, load that up. Now we can see that we have darkened the background while keeping our foreground color. If we change our tint, change it to blue, we've tinted our foreground and then darkened our background based on the distance. Now, if we don't want to completely make the background pure black, what we can do is before we do this 1 minus, we can clamp these the scene depth information to make sure it doesn't get too large. So here we'll clamp it between 0 and our maximum. Our maximum we can create into a parameter. Here let's call this max distance darkening. So this will be our max distance darkening of how the maximum distance of an object from the camera will get for its darkness value. It will be made more apparent. Let's connect this up. So we'll see it doesn't get pure black in the background. We'll have this set to a value of 0, so this time it won't work. Let's increase this to a value of 50. We'll tint it a little darker. Bring this all the way up to like 5,000. Tint it very dark. Let's do somewhere in the middle, say 1,000, 2,500. Clamp our maximum darkness here. We can choose what the darkest value of this dark background fog is. We can use that to our advantage when we apply this post-processing effect to our health. Now we can save and close this post-process material. Look at our post-process material instance. In here now we have our options for our max distance darkening, offset, and our tint. And these we can change back and forth in real time. And these are what we will use during the game to change our effects based on our player health. So for now, let me reset those. To control this post-processing material, we can create a new class. Let's open up our browser. In Blueprints, we'll create a new blueprint class from actor. And this blueprint will control our post-process. Let's call it BP post-process controller. Before we forget, I'll just drag it into the world for now and open that up. Make this full screen. Here in the event graph for our post-process controller, this actor will need to know what the player's health is at certain times and modify the post-process volume to reflect that health. So in our event play, we could delete these other events. We'll need to get some initial information. We'll need to get the post-process volume. In here we could do get actor of class. This get actor of class can be a slow operation since it has to search through all actors in the world until it comes to the proper class. But since we're doing this just as an event begin, this only occurs once during the whole game. It'll be fine for now. You can always optimize this later if you absolutely need to. Here we'll look at post-process volume, and we'll save a reference of this as a parameter. Over here, we'll call this post-process volume. We'll also need some way to modify the material that is in our post-process volume. We could do that using a dynamic material instance. So if we right-click, we can look up dynamic material instance. And here we'll find create dynamic material instance. So this will allow us to modify the material during the game. Here we have to choose a parent. This will be what material we choose. We'll look up mi post-process. And we can leave these as our default values. Then we'll go ahead and save this as a variable so we can have access to it later. And name this as dynamic material. We'll also need some way to track the player's health. Let's go look at how the health is currently set up in this third-person character. In here, your method of implementing health can be different, but we can use an event dispatcher in any health system to use this post-process controller. So in this example, we have a projectile that causes damage when it collides with the player. This damage is then subtracted from the player's health. And this system checks if the player's health is less than or equal to 0. If so, then we'll ragdoll the player. From here, we need some way of letting the post-process controller know that the player's health has changed. So one way we could do that is with an event dispatcher that'll notify the post-process controller that an event has occurred. So here we'll call this event dispatcher health changed. In this health changed, we'll go over here to the details panel. Under inputs, we can add parameters, add 2 of them. The data that we can share with the post-process controller can be these inputs. So here we'll share the health, which is a float, and we'll also share the max health, which is also a float. This health and max health can allow the post-process controller to know how much the player is damaged. Now we can drag in our health changed event dispatcher and call it. We'll call it if the player is not dead. And I'll also copy and paste it and put it at the end here if the player is dead. So if the player is not dead, we'll set the health as the current health and the max health to the max health. And when the player is dead, we'll just set the health to 0 and drag in the max health. Now, if we look back at our post-process controller, we need some way to bind to that event dispatcher that we made. We can find the player character in the world and then bind to the event dispatcher on start. So here we'll find the player character, cast that to the third person character, since that'll be the character that we're using. Stack those up. This third person character we can bind to our health changed. So bind to health changed. So now anytime the player gets hurt, it'll call this health changed event and tell our post-process controller that the player's health was changed. Now here we need to assign an event. Drag off our event and let's create an event dispatcher with a create event. This will allow us to put functions in here. We'll click on the select function dropdown. Let's create a matching function. This automatically generates a function with the proper input pins. If we look back at the event graph, now this event is connected to our binding of the health changed event dispatcher. So let's look at our new event that was created. Let's just rename it as OnHealthChanged. Here we can look at determining the ratio between the health and the max health to see how much damage the player has sustained. So we'll divide our health by our max health to get that ratio. So if the health is at 50 out of 100, then we're at 0.5. And we'll promote this to a local variable called, let's call it health percentage. Connect that up. Now that we have this health percentage, there should be a value between 0 and 1. 0 meaning the player has died and 1 meaning the player is at full health. We can use this value to modify our post-processing material. So let's look at our post-process material again. I'll drag that here so we can see it. So we can modify our max distance darkening, offset, and our tint based on this health percentage. So in order to modify these values in our post-process material, we can drag in our dynamic material. And off of this, we will set a parameter. In this case, let's first do the color. So this color will be a vector, set vector parameter value. Can connect that to our health, or to the previous health percentage node. Name this tint. And we can set the color here to any color that we want. And we'll look into setting that color in a minute here. But let's first create our ways of modifying these other two values. We'll take our dynamic material. This time, instead of a vector parameter value, we'll set a scalar parameter value. Connect that. This one will be called offset. And then we can copy and paste that to get our last parameter. This last one will be our max distance darkening. Now these names have to be exactly the same. Otherwise, the data will not be passed from this blueprint into our material. Now I'll leave those as 0 for now. What we need to do is to apply these changes. So we've changed our dynamic material, but we actually need to modify our post-process volume. We'll go ahead and close this window. Now, after changing these parameter values, we will modify our post-process volume. We'll set our post-process settings in the post-process volume. Let's drag in our post-process volume. We need to get our current settings so that we can keep all the other settings in that post-process volume besides the material. From our settings here, let's set that as a local variable. Let's just call it local settings. And then we can use this local settings variable to modify our dynamic material and then apply that back to the post-process volume. So to modify these local settings, we can drag off, and we'll see here at the bottom there's a set members in post-process settings. This will allow us to set various elements in the post-process settings. On the far right, there's all these pin options. I'll right-click at the top and hit collapse all and just open this top one so we can see all of them laid out. Under rendering features, there's an option for our post-process material. We'll select that as a pin. We can see that appear now on the side. Now let's look back to understand what this post-process material is. Back into our map, select our post-process volume and scroll down to where we added our material. Look under post-process materials, an array. So this is actually an array of materials that you can choose weights for. So you can have multiple post-processing materials in this volume and choose how much each material affects the overall look. But here we're just using our single post-processing material with a weight of 1. Let's return to our post-process controller. With that in mind, we'll need to make some way of telling this post-process materials that we have a weight of 1 for our dynamic material that we've been working on. So we'll drag off of this. There's an option here for make weighted blendables. That's what this option is. We can make an array. And here we'll type in make. We'll make an array. So this is now our array of materials. If you have multiple materials, you can keep adding pins for how many you want. We'll just do our 1, drag off of that, make our weighted blendable. So this weighted blendable is our material with how much weight it has. We'll give it a value of 1 since it's our only material. And for our object, you could select the material, but instead we'll use our dynamic material that we're modifying. There, so we line all that up. We set our dynamic material in our locally stored settings. Let's save this struct out and override that as our new local settings. And we can now apply that into our post-process volume. So we'll grab our post-process volume and set settings. We'll set our local settings as our new post-process volume settings. Now, if we look back at these, right now we're setting it to have a color of black. So let's just make sure that this works. And when the player gets injured, that the screen turns black. There we go. So that means we've hooked up our material properly. Now we can change the actual properties of these values that we're setting in our material based on our health percentage. So one way we could do that is to create different variable curves that completely show the change from full health to 0 health. One way we can make these curves is go into our content browser. We can right click. Under miscellaneous, there's a curve option. And here let's do our color first. So we'll choose curve linear color. And let's call this C underscore health tint. We can open this. So here we see a curve that we can then use to change the color of the world based on the player's health. So let's think of it as 0 being no health and 1 being full health. On 1, we'll leave it as white, so there'll be no tint. And when the player has 0 health, let's go up here, right click and choose a color. Let's tint this to be red. Let's go all the way red. Maybe somewhere in here. Great, so we could save that. Go back to our post-process controller. Now to get access to that curve, we can create a new variable. We'll name this tint curve. And this will have type curve. But in here, there are many different types of curves. So we have to make sure we choose the right one. If we scroll down, there will be a curve linear color. We'll drag in our curve linear color. We'll save and compile. And in this, we can set our default tint curve. So in here, we have a health tint. From this tint curve, we can get a float or get a value. Oh no, this one's the color. Get color, get linear color value based on some input value, which will be our health. Since our health ranges from 0 to 1, then we grab our tint based on this range of 0 to 1. So when the player dies, then everything should be more red looking. Back to our post-process controller, we can grab this color and use that for our input to our dynamic materials tint. Now let's make some curves for these other parameters. Let's make a new curve under miscellaneous curve. These ones can be floats. Call it C health offset. Open that. Now here we'll have to add 2 keys. There are no keys in it to start with. Our first key, let's say 6,000, and add another key at 6,000. We'll all hit F to find them. Now we have range from 6,000 to 6,000. Let's determine what values we want in here. So this will be our health offset. Let's open up our post-processing material instance. For our health offset, here our default was a value of 5,000. So let's change our full health back to 5,000. Let's change the offset to a value much lower when the player gets damaged. This way the darkness kind of comes in towards the player as they get injured. Maybe let's try going down to a value of 2,000. For this first keyframe, we'll do 0, 2,000. Pull up all of them. Go ahead and just add this to our top bar. Now we have 5,000 at a distance of 5,000 for our darkness fog at full health and 2,000 for no health. We probably don't want this fading in immediately, even when the player gets a little hurt. We can drag this over. Let's do half. So when the player gets half health, then we'll start fading down. One thing we can do is Control All. And let's use cubic interpolation to nice ease in and ease out for this curve. Back to our post-process controller. We can make another variable for our new curve. Let's call this offset curve. And this one instead will be a float curve. Drag that in, save and compile, and we can set the default value. Oh, here, this is the wrong type. We cannot set a default value because I did a structure float curve, whereas instead we need a float curve that's an object type float curve. I'll change the variable. So here some of the structures have the same names as our objects. We need to make sure we grab the right ones. Save and compile. Now we have our option for the offset curve. Do our C health offset. From this, we can get float value, drag in our health percentage variable, plug that into our material parameter setting for offset. Now that should change as well as our color. And then last, let's set our max distance darkening. We can go back to our curves. Let's copy our health offset and rename it as health max dist dark. Open this up. For the health max distance of darkening, we want it to get darker as the player gets more injured. So let's look back at our MI post process. Our default value here was 2,500. Maybe we can have that somewhere in the middle of our curve and start the player at, let's change this last pin back to full health and find it all again. So this last pin can be 1, let's say 0 darkness, and the pin at 0 health, let's set it up to a value of 5,000 so that it gets much darker as the player is injured. Go to our post-process controller. Here we'll have to make another curve. We can create a new with type curve float. Let's name this max dist dark curve. Drag that in. Set the default value, health max dist dark. Get float from our health percentage and connect that up. Now we should be modifying our color offset of our darkness fog and the total amount of darkening that we apply. So let's save, let's go test that out and see if we like how it looks. So here we have different amounts of damage. Oh, let me close this. Our default post-process values should match our full health values. So we did 0 on our distance darkening. But we should have 0 health or 0 darkening when we're at full health. So here we're getting damaged 1 at a time. Look at 10 at a time where we've tinted it red. Gets darker every time. Let's look at our go down by 20. Now we have darkness in our background. Everything's tinted red. And then our full red and darkness when we lose all of our health. With this, you can kind of change any parameters that you want. So let's say we didn't want this health tint to be completely red at the end. Let's say we wanted this to be, we can drag up the blue, make it more purple, drag our green up a bit, more pink. So we can do all sorts of things here with our different colors, but we could also add a new color in the middle. Whoops, on the bottom here. We'll have to add a new key. Now this new key, we can choose our color. So we could dip to a color and then choose another color as a dark red at the end. You can control the gradient of the color as the player gets injured. Let's leave that up as we play so we can see the full the full gradient. And let's try it again, see what our new color palette looks like. Go over here, get hurt by some 20s. We've gotten pretty dark here. So you might not want this level of darkness as your player gets damaged, but you can choose how much these values can change. Let's drag up our red so it's not as dark. Try one last time. Go down here, let's get hit by a 50. There. Here we go. Perfect. Well, I hope you found this video helpful. You can use this information to modify any sort of post-processing in your game based on the gameplay, not only health. So here, the sky's the limit, and I look forward to seeing what you create. Let me know.